Yeah, here we look at another example on double integrals over general regions. So the question is we have to evaluate this double integral bounded by this region D by the parabolas. We are given two parabolas, y equals to 2x squared and y equals to 1 plus x squared. For us to determine the limit of integration bounded by this region D, we have to plot the graph. Actually, these 2 points are just curved on a xy plane. For the graph of these two equations, we are going to have something like this. Okay. So we're gonna have x plane and y plane. Suppose we have 1 here and minus 1 here. Let's say 1 here also, minus 1 here, which is on xy plane. If we plot the graph of this guy, y equals to 2x squared, it's going to pass through the origin. So we're going to have something like this. And this guy, if we plot the graph of it, we're gonna have something like this, in which they are going to intersect each other. Sorry about my diagram, it's not too good, but I stay. So let's say this is the graph of y equals to 2x squared, and this is the graph of y equals 1 plus x squared. So these are the two parabolas, y equals to 2x squared. So to obtain our limit of integration at the point of intersection of these two guys, at the point of intersection, which actually means when y equals to 1 plus x squared and y equals to 2x squared, when they intersect, we're going to have 2x squared equals 1 plus x squared. Subtracting x squared from both sides, we have x squared equals 1, in which we have x equals to plus or minus 1. Hence, our x lies between minus 1 and 1, where this is the lower bound and this is the upper bound. So we are already given two parabolas, y equals to 2x squared, y is equal to 1 plus x squared. And for us to know which one is the lower band and which one is the upper band, we have to consider what we obtain here. And this clearly implies that x is bounded below by minus 1 and bounded above by 1. So 0 lies between minus 1 and 1. So assume x equals to 0. If we plug in x equals to 0 here, we obtain y equals to 0. And if we plug in x equals to 0 here also, to this guy, we obtain y equals to 1. So this implies y equals to 2x squared is our lower bound, and y equals to 1 plus x squared is our upper bound. So we are going to utilize this. Let me call it equation 2 and call this equation 1. So these are our limits of integration. Let's evaluate our integral. Our double integral, let's evaluate it. So we have double integral over the region x plus 2y over dA, which is the same thing as minus 1 to 1. When x lies between minus 1 and 1, and our second one, which is 2x squared and 1 plus x squared, I have 2x squared as the lower bound and 1 plus plus s squared at the upper part. So we plug in this guy, s plus 2y. So this is the y, this is the s. We can now integrate now. We have to integrate first with respect to y. If we integrate first with respect to y, we're gonna have sy plus 2y squared over 2. Evaluating the limit from 2s squared to 1 plus s squared. Yes. This guy cancels each other. So we're gonna have minus 1 to 1. When we plug in y plus s squared in terms of y, we're gonna have s to 1 plus s squared plus, by substitute when y equals to 1 plus s squared here, we're gonna have 1 plus s squared all squared. Then close the bracket. So we're gonna have, for the lower limits, we're gonna have s into 2 s squared plus 2s squared all squared. Yes. So now let's open the brackets. Up minus 1 to 1 s plus s cubed plus, when we expand this guy, we're gonna have 1 plus 2s squared plus s raised to power 4. Let's still close our bracket. When we expand this, we have 2s cubed plus 4s raised to power 4. Yes. So we have, okay, subtract, okay, there's no s here, so s remains. S cubed here minus 2s squared, that's minus s cubed. 1 here, there's no 1 here, we have plus 1 plus 2s squared. S raised to power 4 minus 4s raised to power 4, because we have negative sign here. So we have minus s raised to power 4 minus 3 s raised to power 4. Yes. We can now integrate with respect to s. When we do that, we're going to have s squared over 2 minus s raised to power 4 over 4 plus s plus 2s cubed over 3 minus 3s raised to power 5 over 5. Evaluating from minus 1 to 1. Substituting 1 here, we have 1 over 2 minus 1 over 4 plus 1 plus 2 over 3 minus 3 over 5. You have to be very careful here because of those negative and positive sign. Plug in minus 1 here, we have 1 over 2 minus 1 over 4 minus 1 minus 2 over 3 plus 3 over 5. Because s raised to power 5 minus 1 raised to power 5 is minus 1, so it cancels as plus. So we're gonna have half here, half minus half, that's 0. Minus 1 over 4 minus 1 over 4, that's 0. 1 minus minus 1, that's 2. 2 over 3 minus 2 over 3, that's 4 over 3. Minus 3 over 5 minus 3 over 5, that's minus 6 over 5. So take the LCM here, we have 15 here, we have 30 plus, so plus 5, that's 20 minus, that's 18. So we are left with 32 over 15. That's the final answer. Thanks for watching.